Okay, today we are doing 5-5, the midpoint and distance formulas. I really like this section. I'd start by drawing in this little line here on that top graph we have in example 1. That'll give you a chance to get caught up. But yeah, this is just a cool section. There's some formulas that distance formula especially, you're going to keep using throughout your math career. So once you get this thing labeled in there, or drawn in there, I'm going to actually put some points. So I have 2, 3, so it starts at 2, 3. And this end over here is at 10, 7. And if you were to look at that, you maybe pause the video if you're not caught up, but I'm going to keep going. So if you look at that, the midpoint then is going to be right there. If I drew it correctly, the midpoint should be right there, and it's going to be a 6, 5. Well, if we were to take a look at that, well, how do we get that 6, 5? Well, my x value here is 2. My x value here is 10. Do you agree that 6 is right in the middle of those? 6 is exactly in the middle of the 6 and the 2 and the 10. I could do the same thing over here for the heights. My lower height is 3 on the left. My upper height is 7. If you go right to the middle, you get your 5, which then is the 5, the height, and that midpoint. So in order to find the midpoint, we just look at, well, what's the middle of our two x values? What's the middle of our two y values? And when you think about that, really we're just doing the mean or the average. So in other words, if I take an average 2 and 10, I have 2 plus 10. And then because there's two things I divide by 2, I get 12 divided by 2. That gives me my x value of 6. Okay, so the formula then, we want a formula that works for this. So it's similar to when we were doing slope. We want it to work for any points. So I'm going to say my first point here is x1, comma y1. My 1's are a little bit hidden there, but x1, y1. x2, comma y2 for my second point. And it doesn't matter which point is x1 and which point is x2. But now my midpoint, I'm going to do a x sub m for like the x value of the midpoint, and a y sub m for the y value of the midpoint. All right, so once we label up points like that, the midpoint equation, I guess it's not really an equation, I'm going to do a really big point there. My x value is going to be the average of the x values. So to average, we add the x values together, then divide by how many there are, so divide by 2. Then we do the same thing with my y values, add the y values together, and divide by 2. So I got a little ahead. I probably should have done this thing here right now. But if we take that there and move it over here, we could say, all right, my x1 is a 2. My x2, so just kind of lining up points, x2 right there is going to be a 10. And we divide by 2, so that gives me a 6. Then we could do the same thing with the y's. I'll do a little better job of that. So I have y1, which is 3. So I have a 3. Plus y2. So y2 is right there. That's going to be my 7. 3 plus 7. Divide by 2. And that's going to equal a 10 divided by 2, so a 5. Like normal when you're doing averages, make sure you don't just type in 3 plus 7 divided by 2, because your calculator will do the division first. You have to do 3 plus 7 equals, and then divide by 2, or put parentheses in, or just do it in your head. So, all right, that's going to be a normal midpoint one, and as you go through, kind of like with the slope, I would highly recommend, at least until you get good, label your points x1, y1, x2, y2. You're less likely to make mistakes. Another type of question we're going to get is finding an endpoint. And some people hack their way through it. I'll maybe show you kind of how to hack through it. But I'm going to take and kind of use a variant of that red part up above. That we said this here was the x value of the midpoint. So I'm going to write x sub m equals that part on the left. x1 plus x2 divided by 2. And then the y value of the midpoint, so y sub m, is going to be the thing on the left of the comma, this over here. So y1 plus y2 divided by 2. So if you write out the formulas like that, and now if we go through and label up our points, you'll find it really is pretty, I hate to say easy, but it's at least easier. So I'm going to say this point here is going to be x1 and y1. My other point over here, my x and y that I'm looking for, are the endpoints. That has to be x2 and y2. And the thing in the middle, my double 3's, are going to be x sub m and y sub m. So we have those. And now you can just take your points and plug them in. Any questions? Okay, cool. So x sub m is 3 from that middle point, and x sub 1 is 1. X sub 2 we don't know, so I'm going to just put in an x. You could write x sub 2 if you wanted to. Thanks. And now we could go through and solve that side there. So we first multiply by 2. Gives me 6 equals 1 plus x. Then to get x by itself, well, they had added 1, so we do the inverse of adding 1. We subtract 1. So my x value, this point over here, my x value should be a 5. Now we go through and do the exact same thing for the y's. Y sub m, alright, that's going to be this middle point right here. So we have y sub m right there. So I put a 3 in there, equals y sub 1, so that's going to be my 5 from up here at the top. 5 plus y sub 2, that's what we're trying to find. Actually, I'll just write a y divided by 2. Now we do really the similar sort of steps to before. So I start out by multiplying by 2. That'll always be the first step, is to multiply by 2. And we get a 6 again equals 5 plus y. You won't always get the same number there. And then last step, they had added 5, so we subtract 5. And my y value then is 1. So my final point then is kind of crammed in there, but it's going to be 5, 1. That's the very mathematical way to go about it. I recommend learning it that way. I'll mention the other way. The other way is quicker, but it's caused a lot of people grief. So please don't do it this other way on like a quiz or a test, unless you find you can do it and get it right in the homework. But if you're looking at this here, going down, and this is definitely easier if you have a picture. If you just have 2 points on a page, the equations are going to be easier than this. But for this, I went down 2, and then I went over 2. Because down 2 is going from the 5 here, my height of 5 to height of 3. And then going over 2 is going from my 1 to my 3, those two things. Well, you do that same exact thing in finding this other point. You have to go down 2 again. So down 2 more is going to take my y value of 3, make it 2 smaller, make it a 1. And that gives us this 1 here on the end. And then going over 2 more, I'm starting at 3, going over 2 more gets me up to 5. So you can kind of hack through them that way, but that's really kind of dangerous to do, especially if you don't have the graph in front of you. But hopefully I don't regret putting that in the notes. If you flip to the second page you have distance formula. Distance formula is cool. I'm going to get a little off track here. I'll try to be quick about it, but I just think distance formula is neat. We did Pythagorean theorem back in previous life stuff. We said if you have a right triangle, call one leg A, the other leg B, the hypotenuse is C. And then you could go through and say a squared plus b squared equals c squared. So a squared plus b squared equals c squared. And then if I'm trying to teach this in class, usually I say, well, do you agree I could write the c squared over on this side, and it's still a squared plus b squared equals c squared, just kind of in a different shape. But we don't want c squared, we want c. So we could do the inverse of squaring, is to square root. So now I would get c equals the square root of a squared plus b squared. And so we're up to there. And then I would try to convince people, all right, but we're not looking for c, we're looking for the distance. So I'm just going to, instead of my letter being c, I'm going to make it d, which stands for distance. Now, we want to figure out, well, this a value, if I would say, let's say this here is a 5 and this is a 1. It doesn't really fit the graph perfectly, but the distance of a, do you agree you'd subtract those two? So I'm going from 1 to 5. 5 minus 1 gives me 4. Well, instead of a then, we don't want to write it just for 5 and 1. We want to use this x2 and this x1. So a I could write as though it's x2 minus x1. That's the same as 5 minus 1. We have to square a. And then plus, we need to do the similar sort of thing for b. For b, we're looking at this height difference here on the side. Well, that's going to be, I subtract my y values. So b is going to be y2 minus y sub 1 squared. So in other words, my distance formula then is that thing right there. So hopefully, I just think it's cool. But so memorize that distance formula. Looks like I can't erase those, unfortunately. But memorize that distance formula. It's going to come in handy. It's going to keep coming back. So distance formula, let's say we want to use this now to find the distance between some points. Maybe I'll go and actually write it up here in red for dramatic emphasis. You can kind of pick what you want to do. But this is pretty much going to be a guaranteed test question. First page of the test, I'm going to ask you to write this thing from memory. And then after that, I'll give you the equation to use on the rest of the test. So that's what I'm looking for. So pause it if you need to get caught up. Otherwise, we're going to go through and knock this last one out of the park, and we will be done. So, all right, I have my points. I'm just going to label them x1 and y1, x2 and y2. And it doesn't matter which point is which. Often I'll try to have the one with a higher x and or y be the y2s and x2s, because then you don't get negatives as you do the problem. But it doesn't matter. All right, so if I do my square root, a big old square root, x2, so x2, I can copy that down. That's 8 in the problem to the left there. Minus x1, x1 is 2, so I get an 8 minus 2 squared, plus y2, y2 is a 7, minus y1 is a 3. Let me square that. I'm kind of a stickler for the radical extending past the end of the numbers, so please, at least in answers, if that comes up in answers, at least do that. 8 minus 2 is 6, so I have 6 squared, plus 7 minus 3 is 4, so I have a 4 squared. Now I can't do square root yet. I can't say, hey, square root cancels those out. You have to actually figure out what's inside. It's kind of like there's a hidden set of parentheses in there. A radical is like a grouping symbol. So I'm going to scroll up a little bit. So I get square root of 36 plus 16. So that's going to be square root of 52. So if you want the exact answer, I suppose you could leave it as square root of 52. But if you take and punch that into a calculator, that's going to round. And it's going to tell me it's 7.21 if I drop some decimals and just round to 2 digits. So 7.21 then is going to be the length of this black line segment connecting those 2 points. So that's it. That's midpoint distance formula. If you have questions, let me know in class. I'd be glad to help you. Thanks for listening all the way to the end.